All right, thanks everyone for showing up to my talk, which is about monitoring our minimum viable security on Windows with OS Query, which is a topic that we don't discuss too often on the Windows side. So my name is Guillaume. I've been doing some blue team and Windows stuff for a very, very long time now. I love OS Query, and I have this Windows background, so I want to use it more on Windows because of that. And I work at Optics where we do OS Query at scale, which is, it's not a coincidence. I work there because I love OS Query. So this is a follow-up to the ops talk I did last year. Before we get started, yesterday Gadi was saying that dropping F-bombs at the conference was okay, and it just reminded me of the Canadian government deciding that it's not vulgar to do it during a French broadcast, which I thought was a pretty cool way of bending the rules. So what did we talk about last year? We didn't talk about Brooklyn barbecue, which was the stupidest thing I read all year. We talked about reducing the effectiveness of attacks without impacting user experience on Windows. So I have a 1-minute summary of it. You take a guide like the CIS benchmark, it's like 1,000 pages. A lot of the things in there are good, but there's also a lot of stuff in there that's nice to have, but doesn't really have anything to do with the attacks you see day to day. So we picked close to 10 settings, push those settings to a few hundred or 1,000 machines used by interns and at-risk users, and we realized a 78% reduction in like off-the-shelf malware and just noise that gets created for the SOC. So I thought that was really significant with only a few settings. So if you weren't there, you just say 44 minutes because it was a pretty detailed talk, but through this one, I'll show the actual settings we were talking about. So how do we track our progress? We knew what we had to do, but tracking it is a different story, especially if you work in an enterprise environment that's got 32 different business units, all running different software management suites and all of that. So first, I figured we should make a list of the things that we wanted to fix. So the first big one was lateral movement. There's so many companies got wiped by ransomware a few years ago, and it's still a problem. So what's lateral movement? Well, it's a problem created by a combination of network access to these machines and credentials, right? So there's a few things there that we needed to fix. Macros downloaded from the internet, still a big thing. Actually pretty easy to fix on Windows with Office 2016 now, and a dual browser setup. So I'll give some more details around the dual browser thing later. So the first thing, lateral movement. I think in most environments, there's no reason why your workstation should be accepting traffic from another workstation on port 445, right? So last year, pretty much everyone agreed with that. And you typically have some systems, maybe you have SCCM, something that's pushing software to your workstations that needs to be able to connect using those protocols. But you should have a pretty good idea of what the address space that should be coming from. So assuming 10.0.99.0/24 is my management zone, obviously, it's probably way more complicated in the real environment, but that's just for my VM. I figured, what do I do with OS Query to be sure that I'm protected against lateral movement at the network layer? So the issues I had were that OS Query doesn't have a table for the Windows firewall. It would be much easier to do that with IP tables or the application layer firewall on Mac. Not everyone uses Windows Firewall, right? Like most of you probably have some kind of AV vendor that also has firewall features in there. It gets complicated pretty quickly. And the Windows Firewall has all these different profiles, right? Like, are you on a domain? Are you at a Starbucks? Whatever, so it's different. So it's pretty hard to understand what the rules are. So I figured I had two options. I can read the rules to see if they're appropriate, or I can just monitor for any inbound traffic. So to read the rules, the great thing about OS Query on Windows is it can read the Windows registry. Okay, so we're going to have a lot of examples here. This is pretty much a real query except for the blah blah portion in the middle because it's like 62 pages wide. Yay, Windows registry. But the problem is when we read that, it looks like this, right? Like it's this big mess of like pipe delimited and there's so many fields. So do I really want to try and understand what that means? No, probably not. So I figured a way more lazy or efficient approach would just be to watch, right? Windows is so noisy when people are browsing like my network places and all of that. I don't even need to check that the firewall is configured properly. I just need to check if anyone is connecting to it that I'm not expecting. The advantage from that means it worked in every business unit that I had that all use different software firewall stacks. So there's a process open sockets table on OS Query, which lets you see what sockets are open. So it's actually extremely easy to create a query. that is looking for anything that's not your local host or your expected management subnet connecting to port 445. So if I ran that, I would get this, and I would know that my address ending with 15 received a connection from the one ending with 4, which is not whitelisted. So now I know I have a lateral movement problem. It doesn't make any sense that these two workstations would see each other on port 445. So it's a pretty short talk, so I can't go over all the basics of OS query, but you'd want to take that data and query it every few minutes or so and send that to somewhere where you can just monitor that all the time. And once you've done that, might as well do it for remote desktop, WinRM, even SSH on different operating systems, because it's going to be the same case, right? You probably don't want the person working right next to you to be SSHing into your Mac. Well, that same query is going to work. You just change the ports, and it's going to work on Mac and Linux as well. And same thing for remote desktop. So that takes care of the network access. Then last year we discussed Laps, free tool by Microsoft just to randomize local accounts on Windows. It works really well. But you want to be tracking that it's actually been deployed in all these environments where you may not have so much control. So again, Windows registry, all the settings are in there. So you probably will want to monitor the settings that control, is it enabled? What's the length of the local administrator password going to be? How often they get rotated. So that's another really easy example. You just query that path in the registry, and I'm going to put the slides right after, so you can even copy paste. They should all be working queries, and you get this. You get a table that tells you exactly the values that go with each one of these. So doing that with something like WMI, for example, like all the data is accessible, but the great thing with OS query is you just schedule it and it runs over and over, and it's super high performance, which means that it's actually less dangerous to deploy than a lot of other solutions. So now we know how Laps is configured. In a real world environment, you would have two options. Either you query that and you send it to a central database where you monitor, or you may want to tweak that rule to say, okay, I know like my password should be way more than 14 character long, so I want to get results only if it's like less than 32 or whatever. Which you would do like this, right? So for example, this would only return something if the password value was set to 31 days or more. So I would know if I'm not getting any results from a machine, well, the passwords don't expire often enough. Or they get that backwards. Now that we fixed the passwords, we want to know, is that actually working fine? So there's a Windows events table in OS Query. I don't have time to get into the whole events thing. It's actually pretty interesting. All you need to know before you start digging is that it lets you specify the events you want to centralize, right? So no one wants to do like full every endpoint to the SIM, right? Well, I guess your SIM vendor probably wants you to do that. But you can make a really specific list of events that you want to grab with OS Query and send there. So in my case here, event 4724 would indicate that the local admin account was reset by Laps properly. And Juju or JT is someone I used to work with. He's got a bunch of Ansible packages for configuring things like sysmon and OS Query on Windows, which sometimes it's pretty hard to get a hold of. So you can check in there. We have a great list of events to monitor. So we fixed the network. We fixed the local administrator password. The next thing we should be worried about, and it's probably pretty small, but one of the big issues with ransomware and lateral movement is just the amount of credentials that we have in memory on systems everywhere, right? Like everyone's got the workstation, there's service accounts, IT is pushing a package, there's an account with a lot of privileges. So there's a logon sessions table on OS Query, and it works really well on Windows. So what it lets you do is see what sessions are live when you run it, which, okay, so here I have a column for users, what domain they're in, what domain controller that came from and all of that, which that's interesting. But last year we talked about restricting service accounts so that humans could only log in an interactive manner and services could never do so, right? So you're a computer, you don't log into an interactive interface and vice versa. So if you have a naming convention for that, for example, if your service accounts start with like SVC underscore and your highly privileged accounts start with something else, you can leverage that with that table really quickly. If you don't have that, actually Justin's Turbo Talk from a few minutes ago, I don't know if he's here, dumping all your Active Directory stuff to the same database where you will send your OS Query results would be really interesting, because then we have a column called logon type. And it tells us exactly which session is interactive or not. So if we combine that with what we just said, which is, okay, my service accounts start with SVC underscore, I can create a query reading the UPN, the domain name, where the account starts with SVC underscore, and the logon type is interactive. So if I run that on all of my machines, I will instantly have a list of accounts that are not service accounts, that are service accounts, and that are logged in interactively. And then you'd probably just do the other way around, right? Like anything logged in as a service that doesn't start with SVC. So now we know what our credential exposure is. So another issue that's pretty common, depending on the environment you work in, people try to get local admin privileges in any way that they can. So this is an interesting example because it's going to allow us to use wildcards in OS queries. So sticky keys, basically the trick is for those that have never done it before, sticky keys is an accessibility option in Windows that lets you use the keyboard instead of a mouse, right? So don't be a dick, don't disable it if people need it. You need an option for people that really need it. That being said, by default, it points to an executable, and sometimes the permissions on that executable or the registry key that points to it are weak, and people just replace sticky keys with cmd.exe, for example. So remote desktop to a machine, hit shift 5 times, and instead of sticky keys, you get a shell. So you can disable sticky keys for users that don't need it. There's GPOs for that and all that. The value you're looking for in the registry is 506, which means it is disabled. Now the thing is, the Windows registry for user settings is like the current person logged in is HKey current user, right? But on a workstation, you may have 15 different users that logged in at any point. So the trick here is you need to map that back to a user, right? Like it's a setting that's per user on top of having the system level setting. So in OS query, and I don't know if this pointer works here, yay. You can use a % sign here as a wildcard. So what it's going to do is it's going to go through all the different registry hives that you have to look for keys that look like that, which is a good start. Now we get that. Okay, so 510, which is not the value I want, and then I have the registry path, but that doesn't really tell me who these users are, right? Like you have the Windows SID in there. The Windows people will recognize the first few, and then the last line is the test account that I had created. So corporate environment, you want to know what account doesn't have the right rules applied to it. You can't just get a list of SIDs, especially since you're looking at local registry here, and you need to map that to Active Directory. So this is when it starts getting fun. So if you're familiar with SQL operations or anything like that, even regular expressions, you'll see exactly what I'm trying to do here, which is OS query lets you split a column based on a specific pattern, right? So it's Windows, so there's backslashes everywhere, right? If we go back to the previous one, what we really want is what's after the first backslash and before the second backslash. That's it. So I'm going to select my username, I'm going to select my data, and then I'm going to split the path column where there's a backslash, and I want the first value after the first backslash, and I'm going to call that column reg UUID for registry UUID. From a subquery, which is the query I was showing before. And then what do? You join that to the users table in OS query, which has a bunch of information about your users, including the actual UUID, which on Windows is the SID. So we now have a way of mapping this registry query, this registry setting, to an actual user. So here we see the actual user's names. And there's a bunch of other fields, so you could even map that back to like UPN and all of that, and you could get a nice list of actual end users not configured properly on specific hosts, right? Because the way GPOs work in loopback processing, maybe you're logged into your Windows laptop, everything is fine, but maybe when you're doing terminal services somewhere else, it's not. So with that, you'll know. So the next point we had was Microsoft Office. So Microsoft Office 2016 has a setting, I believe they ported it back to 2013 in an update called block content from internet, right? So you want that to be there and be set to 1, right? You don't want to be prompting users to execute macros on things that come from the internet because they want to open a file. So of course they'll run a macro. So every file that gets downloaded or through like Outlook or your browser is going to get metadata on it, and then Outlook won't run it. Now, again, it's typically by user. Most people configure Office by user. There's some settings that are at the computer level. And on top of that, Office does it per app, right? So Excel has all of its settings, Word has all of its settings, and it can get into a pretty big mess pretty quickly. So I'm going to zoom on that. All right, so we already knew we had to use a wildcard to match the users, right? So it's the same thing. We have a user's SID right here. And then what you want to do is where you see Word right there is just replace a second wildcard. You can actually have multiple wildcards in the same OS query command. That works really well. If you're trying it with the interactive version of OS query and you're getting like weird errors and you're not able to execute it, there is currently a bug in OS query, just the interactive version. The query works once and then you have to quit and restart, but it's going to get fixed soon. All right, so we now monitor our Office environment for the right setting for all the users, for all the different apps. So the next one is the multi-browser deployment or dual browser deployment. So one of the things that's the most valuable in Windows 10 in terms of security, I think, is the fact that you can use tools made for compatibility reasons for security. So Edge is not compatible with a bunch of corporate websites. You probably have like some kind of terrible security awareness thing that only works in Internet Explorer or whatever. Kind of ironic. But Microsoft has put compatibility tools that we can leverage there. So what we want to do here is when people open up a browser, if they type google.com and they're in Internet Explorer, you want to be shutting that down, sending them to Edge. And if they're in Edge and they're trying to go to terrible security awareness.corp, you want to be sending them to Internet Explorer so it works. And you probably want to be deploying Chrome and an ad blocker at the same time. That's actually pretty funny because last year I was saying Chrome is going to start blocking ads soon, so maybe we won't need that anymore. Turns out we still do, and now there's a bunch of changes coming up, so I don't know what's going to happen with some of these extensions. So I guess we'll see next year. So yeah, so sometimes I call it a dual browser strategy, but it requires like 3 or 4. I just figure have more browsers, make sure they're configured properly, and then use a tool that's cross-platform like OS Query to ensure that it's done everywhere. So you'll query, again, using a wildcard for a configuration item called site list. So Microsoft lets you create an XML. They have tools for that. That list is basically the whitelist of sites that should be opened in Internet Explorer. Why do we need a wildcard there? Well, because Edge needs to be configured for it and Internet Explorer needs to be configured for it. So you'll run that query, and if you don't get 2 results for every workstation, in this case, it was configured by workstation and not by user, you know you have something wrong. So basically, Internet Explorer won't know where to get the list, and it's going to allow people to pretty much do whatever they want. So once the list is configured, the next thing you need to check is that restrict IE is enabled because that's the bit that makes it kick off to Edge whenever something is not in the list. So as soon as you do that, and it's actually pretty smooth. You just type in a URL and you get kicked to the other one. So you want to be monitoring for that restrict IE. And then, we did like all the users and mapping and joining. So we have some really easy stuff that you should do at the same time, right? Chrome for Business, is it installed? This is a really basic sample for doing it interactively. You probably want to be actually sending the list of everything that's installed to your central repository. And there's the publisher info in there that you can use to make sure it's a legit version. So that's pretty simple, straightforward query. And then we have Chrome extensions, which is my last sample here, which are also configured by user. So using what we've just learned before, we can map to our users table the Chrome extensions table, and then we can know exactly what user does or doesn't have an ad blocker installed. And I've said it many times, I believe that ad blockers are a more valuable security tool than a lot of other actual security tools out there. And now you can really be sure that no matter what machine they're logged into, that they're equally protected, because the people that do it, deploy ad blocking and all of that, pretty often forget to do it on shared environments, right, like Citrix servers and terminal servers, just due to the way they push configurations there. So now you'll be able to track that. And it's going to look like that. So my user is called G, UID, 1001. I have uBlock origin. If that's what you're expecting, then great. There it is. Of course, I would highly encourage that you get the entire inventory of all your Chrome extensions, and you can also check out Chrome unwanted Chrome extensions, which is a nice list of bad extensions created by Nick Anderson at Facebook in the OS Query project. So now that you've seen that OS Query is actually really powerful on Windows, it's not just a tool for Mac and Linux. What you should be looking at is what do we really need to get for configuration tracking? Because we already know OS Query is great for hunting, right? So Eric had a talk on open source tools for hunting yesterday, and he showed some really great examples, right? Like monitoring different processes and all of that. But we can also use it to track our secure configurations. And personally, I feel like a lot of configuration management software is overly complicated. With OS Query, it's actually really, really simple. You send the data to a nice repo, and there you are. Use real-time queries when you're doing hunting or to confirm that a specific configuration value was what you expected that it should be at the time of the incident. So for example, we said we want to block execution of macros on files downloaded from the internet. If you check that value pretty often and you keep that data, at some point someone's going to get owned. They're going to have some malware that you think came in through an Office document. You'll be able to right away go back in time and see, would the macro have been prompting to execute, or was it completely blocked? And then if it was completely blocked, then maybe someone used a vulnerability in Office, or the entry path was completely different. So, and then I highly encourage you to watch Eric's talk from last year on Graylog, just because the way you can send data to something like Graylog if you want to roll your own OS Query solution, I think it was really well done, as well as the slides from yesterday, because you had a lot of OS Query Windows content as well. So, does anyone have any questions? Wow. All right. Thank you very much. If there's anything, you can ping me on ACOD Slack or anywhere else, and I'll be happy to help you with some queries.